Hello, beautiful people, and welcome to the part 2 of your practice test. This is your work along with me or check your answers. Let's go ahead and start with number 1. Number 1 is asking you to draw. These are going to be similar to part 1, which is the no calculator, but you'll notice that things are a little bit more challenging because you have that tool of a calculator. So numbers are going to be larger, positive, negative. That will be a difference as well. All right, so let's go ahead and draw an angle. This is going to be your radians. So the first, by your full, your half, and your quarter. So full cycle is 2 pi. Your half a cycle, your quarter of a cycle is pi halves. You're going to create common denominators with this 18. So I'm going to put a 1 underneath here and multiply this one top and bottom by 18. This one top and bottom by 18. And this one top and bottom by 9. So my full is now 18 times 2 is 36. 36 pi 18ths. Here I have 18 pi 18ths. And here I have 9 pi 18ths. So my full is 36, my half is 18, and my quarter is 9. I'm going to go ahead and take out my calculator and identify two things here. I'm going to identify if this is positive or negative. Positive is going to go up. So I usually write a plus in front of my little brackets. And then I'm going to start, you can do this two ways, either add up to the angle or start subtracting. I usually like to subtract. So I do 61 minus, I know I have a 36 in there, so I'm going to write 36 pi 18ths. I have 25 left, which means I can do another 18. And then, so I'm going to subtract that 18. So again, 61 minus 36 minus 18. I get 7 left over for all of this to add up to 61. Now you have to do a mental note, like kind of like an English translation to what you have. Here you have a full, here you have a half. And then on this one, on the 7 pi, you want to take a look and compare it to your quarter. So your quarter is 9, half of 9, 9 divided by 2 is 4.5. 7 is much bigger than 4.5, kind of closer to 9. So this is more than half a quarter. So when we are drawing, oops, let's pretend that's straight. We're going to be going up because it's positive. So up. We're going to go one full cycle. There it is, that one full cycle. Then we're going to be going half. Here's your half. And then you're going to be going more than half of a quarter. So more than half of a quarter. And we're here. Make sure you have arrow on your terminal right and arrow on your angle. Now, the second question is asking you for your reference angle. A reference angle is an angle, you have 4 options from your x-axis. Always touching the x-axis is always less than a quarter, and it's always positive. So this right here is your reference angle. Now, we did get lucky. We do know what that size is without having to compute anything. And that distance, that last distance traveled was the 7 pi 18ths. So we write in that your reference angle is 7 pi 18ths. And that's kind of like your two parts. So part 1 is to draw it. And then the second one is to find the reference angle. Number 2, convert each degree into radian. So this degree here, we're going to multiply by our conversion rate, which is pi over 180 degrees. Don't actually multiply. Technically we are with that 180. But you can go ahead and start simplifying. Now, if I was to type into the calculator 1020 divided by 180, it's going to give me a decimals. Reminder, decimals are not allowed. So second PRB, this will give me a mixed number. So instead, what I do is I cheat. Okay, I cheat. I go ahead and flip it and make 180 over 1020. Okay, this is not the correct way to do it. This is me and this is my cheat. I'm showing you how to cheat, but if you make a mistake, that's on you. That's not on me. Okay. Again, this is decimal second PRB. This gives me 3/17. But I flipped this, so I need to flip that as well. Okay, so again, I flipped what I typed into the calculator, so I'm going to flip the answer back. So that's how I cheat. If you want to do it by hand or if you want to do it in a different way, that is okay as well. Okay, moving on to the next one. We're using that same conversion rate from meridians to degrees. So we got 71 pi over 18, and that's not equal to, let's go ahead and use our conversion rate. We're going to times that, but this time our conversion rate is going to be flipped. I want degrees, so degrees is going to be on top. The other one for question number 2 wanted radians, so radians is on top. Okay, again, don't actually multiply things out, just write it out. Oops, that's it. There's nothing else in the numerator. Oh, there was a pi. The pi's go away. Again, you don't have pi in your degrees, so that's fine. And again, you can choose to multiply things out. You can simplify by hand. So I got 12780 divided by 18. And I get 710. Now, if you don't put the degree symbol, it will be wrong because what are they asking for? They're asking for degrees. So make sure you give degrees. Okay, next one. This one's asking for a positive and negative coterminal angles. Coterminal angles are angles that start and stop at the same location. However, their size and their direction could be different. I say it's the difference in the loop-de-loops, in the difference of the revolutions, the cycles, the periods. Okay, so all you're going to do is you're going to add and subtract a full cycle. That can be 2 pi in a radian, or it could be 360 degrees, 4 degrees. This is radian, so I'm going to add 2 pi over 1. Now, common denominators are required, so I'm going to multiply top and bottom by 12. So I am getting negative 19 pi 12ths plus 24 pi 12ths. And negative 19 plus 24, that's equal to a positive 5 pi 12ths. Now, they are asking for one positive and one negative. So I'm going to go ahead and do this again, but this time I'm going to subtract a full cycle. Now I already know that a full cycle common denominator is going to be 24 pi 12ths. So that's what I'm using here. So negative 19 minus 20, negative 19 minus 24 is negative 43 pi 12ths. Okay, let's go again. This time they're giving us degrees. So I'm going to add 360 degrees, and then I'm going to subtract 360 degrees. 60 plus 360 is 420 degrees. 60 minus 360 is negative 300 degrees. And again, this one is asking for both the positive and the negative coterminal angles. All right, moving on. Number 6, in question number 6, they are asking us for the length of each arc. So what the actual question is asking is the distance here, this size right here, this on the outside. So we do have a formula that we need to have memorized for arc length, so arc length, and that is S is equal to R times your theta. So R is your radius, and that radius is going to be this right here. And your theta is your angle, but this angle must be in radians. So step number 1 is taking your given angle and converting. So to convert to radians, you're going to take 225 degrees, multiply that by our conversion rate of pi over 180, and that's equal to 225 pi over 180. Now, this is not simplified. You must simplify. This is calculator portion. So you can do this by hand or you can go ahead and use a calculator. So the way that I do it, I cheat. Okay, so instead of typing in 225 and 180, I do 180 over 225, knowing that this is wrong. Like I understand that what I typed into the calculator is wrong. I know that 225 is a bigger number, 180 is a smaller number. But if I put the smaller number on top, the calculator will simplify it for me. So I know I need to flip this. So my simplification is going to be 5 pi over 4. If you do this method and you make a mistake, that is on you, okay? Otherwise, please simplify regularly. So this is going to be your theta. So for the actual formula, we're going to say arc length is equal to the radius of 16 times your, what was our angle? 5 pi over 4. So you want to put a little 1 underneath here and multiply straight. So we have our length of 16 times 5, which is 80 pi over 4. Again, that needs to be simplified. So we're going to go ahead and simplify that. 80 over 4 divided by, oops, delete, divided by, and so we get a length of 20. Now, we do have units, right? We're talking about length, arc. I am okay here if you write units, or if you just honestly leave it, it's not going to be the end of the world. Okay, moving on to the next one. Oh, your next one is actually asking for area. So similar looking question, but in reality, you're using a completely different formula. So we are going to be looking at an area formula, which is 1/2 times our radius squared times theta. Okay. And then this one's kind of bothering me to be, so let me backtrack a little bit of what I said. Let's go ahead. We do know the units. We don't want to write just units because we know what that is. The units here is yards. So let's go ahead and make sure it's yards. Okay, so don't forget your units. I said it's not a big deal. It actually is a big deal. So please ignore my previous statement and write your units. Okay, definitely write your units. All right, moving on here, let's go ahead and area. So area is the inside part that we want. And this is the area that they want us to solve for. And again, just like before, we need to convert. So this 240 degrees needs to be multiplied by our conversion rate of pi over 180 to 40 pi over 180. Again, I'm going to cheat on a calculator. I'm going to flip my numbers. You don't always have to do this, just when the number is bigger on top that you might need to cheat a little bit. And so again, I'm going to flip that. So 4 over pi over 3 is my simplification for theta. My radius is 15. My angle is 4 pi thirds. And we still have that 1/2 here. So my recommendation for doing something like this is you're going to put a 1 underneath it, and you're going to multiply straight. So we got 15 squared. You can even do it all at once. 1 times 15 squared. You can use parentheses. It's just squared. Use the square button. Times 4. Do not type in your pi. And here we have 2 times 1 times 3, which is 6. Simplify. 900 divided by 6 is 150. So area is equal to 150 pi. Again, what are our units? We determined that a few seconds ago. Units are important. Units are inches. And what are we trying to solve for? Area. Area is always squared. So don't forget your units here. Okay, moving on. Find the value of the trig function indicated. This one's asking for tangent. So with a question like this, anytime they use sine, cosine, tangent, or the reciprocal functions, secant, cosecant, cotangent, you want to have right triangles. This is right triangle trigonometry. So tangent of theta goes to so, ka, to is your opposite over adjacent. So you're going to take a look at this triangle. Here's your eyeball. You're going to identify your opposite, your hypotenuse, and your adjacent. So in order for us to identify the ratio of opposite over adjacent, we need to know this third side. Because we have a right triangle, we can use our Pythagorean theorem. We go a squared plus b squared equals c squared. A and B doesn't really matter. We can use A for our adjacent, B, and then C is the most important part. So C must be your longest side. It must be your hypotenuse. So we have A unknown plus 7 squared equals 15 squared. Again, using a calculator, we got 15 squared, which is 225. Here we got 49 plus unknown, subtract 49, 225 divided by 49. Oh, not divided by, 225, subtract 49. I get 176. Now, 176, if you try to take the square root of that, it will not be a pretty value, but you still need to break this up and make sure that you are simplifying your radicals. So I'm going to go ahead and start typing into my calculator 176 divided by, and I'm going to test out my perfect squares until I'm unable to simplify. So for example, 4 is a perfect square. However, I still can remove another perfect square from that, which is another 4. So I'm going to try to do 16. 16 is a perfect square. 11 cannot be simplified. So we're going to break this apart to 16 times 11, both square rooted. That means the square root of 16 is 4. So 4 root 11 is what we have here. If you, thinking bubble, if you do not simplify your radicals, that will be wrong. Okay, will be wrong. So my adjacent, our adjacent is 4 root 11. So then tangent of theta, opposite was 7. Adjacent is 4 root 11, which means that we need to rationalize. I'm going to multiply top and bottom by the radical of 11, square root of 11. Tangent of theta is equal to 7 root 11 over 4 times 11, which is 44. And I'm kind of running out of space to write these answers, but let's go ahead and try to make it work. Tangent of theta is equal to 7 root 11, square root of 11, over 44. This right here is your answer. So make sure you simplify your radical. Make sure you rationalize the denominator for your answer of opposite over adjacent. Now, if they're asking you to find the angle measure and the question looks like this is a level 1. All the information is given to you. All you need to do is use inverses to invert your input and output. So now you're going to have 2.2460 equal x. And so this tangent is now going to be inverted as the inverse of tangent. Remember, on the calculator, this is not a -1. This is a symbol for inverse. So you're going to press second. You're going to invert tangent. And then you're going to type in 2.2460, close it, enter. And now this is asking us to round to the nearest degree. So x is equal to 66 degrees because we have a 9 here. Now, if they're asking you for angle measurement, but they did not do the setup for you, this is your unknown, this is your theta. It is going to be your choice. We have a right triangle. And with all right triangles, we can use SOHCAHTOA. And it doesn't matter because here they're giving you all three sides. Sometimes they'll give you two sides, which forces you to use a specific ratio. But here they've given us all three sides, so it really doesn't matter what we choose, sine, cosine, or tangent. Here is our opposite. Here is our hypotenuse. That means this is our adjacent. So let's say if we wanted to use sine, we would write sine of theta is equal to, again, so opposite over hypotenuse. We would use inverses to invert our theta and our 80 over 89. So theta goes on the outside, 80 over 89 goes on the inside, and again, since we're using inverses, we have to invert our sign. This is what you would type into the calculator. Make sure that you're using the correct inverse button. Second, inverse of sine, we got 80 over 89 equals, and again, it's asking us to round to the nearest degree. For us, that would be 64 degrees. So theta is equal to 64 degrees. Okay, let's move on. Find the angle measurement to the nearest degree. So again, this one's very similar to the other question where the information is provided to you. So we're going to use inverses for angles. Again, when we're having a setup like this, you're going to switch the input, the output. So C is now the output. Input is now 0.8480. And that means we have to invert our cosine, cosine inverse here. Picking up our calculator, typing this in, we have second inverse of cosine. And what am I typing in? 0.8480, close it, equals. Round to the nearest degree, so that means C is equal to 32 degrees. Find the measure of the angle indicated. Again, this one's giving us a right triangle. And with right triangles, we have SOHCAHTOA. You can always use SOHCAHTOA. You can always use these ratios with the right triangle. Now, unlike the other question, this one does not provide us all the information, which is okay. This just, here's our eyeball, here's our theta. That means these are opposite. This is our hypotenuse. And this is my adjacent. We are kind of forced to use a specific ratio depending on the relationship that we have with our side and the angle. So we have an opposite, we have an adjacent. So opposite and adjacent means I must use a tangent function. So we're going to write this out as tangent of theta is equal to opposite, which is 4, adjacent 14. And again, our goal is to solve for the angle. Okay, solve for the angle. That means we're going to be using inverses, and we're going to be switching the input and the output. We have 4 over 14 is now our input. Theta is our output, which means we need to invert tangent, tangent inverse of 4 over 14. We're going to type that into the calculator. Second tangent, inverse of tangent, open 4 over 14, close it, equals, we're rounding to the nearest degree, which means that I'm going to have theta is equal to 16 degrees. Make sure you have your units. If you don't have units, it will be marked wrong. Okay, let's move on. Find the measure of each side. Okay, find the measure of each side indicated. Round to the nearest tenth. So first of all, we're now rounding a little bit different, and now we're solving for sides. But again, what do we have? We have a right triangle. With the right triangle, you can use SOHCAHTOA. Let's go ahead and label the first one, 13. Here's your angle. That means this is your opposite, this is your adjacent, this is your hypotenuse. Now, there's a couple unknowns here, and that's okay. You got to read the question. You got to basically understand what they're asking. They're asking you to solve for x. So since they are wanting us to solve for x, that side, that hypotenuse side here is important. Next, you want to acquire information that is provided. So the information is provided is the adjacent. So for us, hypotenuse and adjacent is going to tell us which ratio to use. Hypotenuse adjacent means that I'm going to be using the cosine for this question number 13. So cosine of your angle, here's our angle. So cosine of 48 degrees is equal to adjacent over hypotenuse. Now, it's very important not to round here. Okay, don't round. You're going to just start by moving x to the other side. So multiply by x, here's your dotted line, multiply by x. You end up having x times cosine of 48 degrees. Do not evaluate this yet. They remove that. We have 8 here. Next, you're going to divide by cosine of 48 on both sides. And remember, on one side, our goal is going to be to remove. So that side, that cosine of 48 is gone. We have left over x. Here, we're going to be typing this in. 8 divided by cosine of 48. Make sure your calculator is in degree mode. Right? Mine is in degree mode. Close it, equals. And this is asking us to round to the nearest tenth. So 9 and 5, oops, tenth. So 9 is what I'm going to be trying to round to. But that means that I have to look at the number behind it. So I'm looking here. If this number is 5, 6, 7, 8, or 9, then I have to round up to that one, which ends up being a 10, which ends up being a 12. So we have to round that 9 to a 10. So that means my rounding is 12.0. Here, there are no units on these sides, just numbers. Okay, let's go again. Let's label our triangle. Here is our eyeball. Here's our theta. Here's our point of view. Across the street, we have opposite. Here we have hypotenuse. And here we have adjacent. Again, let's go ahead and figure out what they want us to solve. They want us to solve for x, so it's important. And let's figure out the information that they've provided. They've provided an adjacent, which means I need an opposite and adjacent. So for question number 14, opposite adjacent, I'm using a tangent. Tangent of our angle 51 is equal to degrees, is equal to opposite over adjacent. And just like we did here, we're going to start by removing that denominator by multiplying 9 both sides. Unlike the other question, we're kind of done after that. Remove on one side, multiply on the other one. So we have x is equal to 9 times tangent of 51, and you're ready to type that in. When you had an unknown in the denominator, that part was a little bit different. You had an extra step. Here, the unknown was in the numerator, so you're just going to type that in. So we got 9 times tangent. Where's tangent? Tangent's here. 51. Make sure your calculator's in degree mode. And we get x is equal to, we're rounding to the nearest tenth. So here's 10. We're looking at the number behind it. It is 1. So that means we're going to keep it at 11.1. Okay, moving on, question number 15. Use a given point on the terminal side to find the value of, okay. So what this one's asking is we're going to find sine b. Let me backtrack a little bit. This one is asking for sine, but make sure on the exam it will ask you for sine, cosine, tangent, secant, cosecant, cotangent. So make sure that you are able to do a question like this, not just for one, but for all 6 of your values. Okay, step number 1, you're going to identify all students take calculus. This will identify what quadrant your angle is in. It's in quadrant 1. So that means your answer is going to be positive. Okay. Next, you're going to be drawing out a right triangle. So you're going to bring this down and you're going to create a right triangle here. And your point of view of that triangle is going to be on your origin. So it's always going to be looking at your origin. Here's your 90-degree triangle. And they are telling you that the x and the y values. So x is 6, y is 17. So that means the distance here is 6 and the distance here is 17. Again, so for your x and your y. Notice that we do have a missing portion. We do have a missing hypotenuse. This is unknown. I'll just call it C. So we do need to do our Pythagorean theorem. A squared plus b squared equals c squared. Sometimes they give you like square roots here, so make sure that your a, b's, and c's are in parentheses. For this example, it's not a square root, so it's not that big of a deal, but most of the time it is. So we have a and b doesn't matter. So we got 6 squared plus 17 squared. C always has to be your hypotenuse. I'm going to type that into the calculator here. 6 squared plus 17 squared is 325. Then take the square root, take the square root. If we try to take the square root of 325, that gives us not a pretty answer here. So that means what we need to figure out is how to break this apart and make sure that we have trying 25. Oh, there it is. We want a perfect square, which is 25, and we want here a number that will not be able to be simplified by a radical squared. So that means we're going to break this apart into 25 times 13. And 25 square rooted is 5. So we have 5 root 13 as our hypotenuse. And yes, you have to have your radical simplified. So now that we have completed our triangle, it's asking for sine. Sine, SOHCAHTOA, is your opposite over hypotenuse. So sine of your theta. Let's label our triangle. Here's our opposite. Here's our adjacent. We want opposite, which is 17. Hypotenuse, which is 5 root 13, which means that I need to rationalize top and bottom by the square root of 13, which means we have 17 root 13 over 5 times 13, running a little bit out of space, which is okay because I am ready to write the answer, 5 times 13, which is 65. So I'm going to bring that up here and say we have positive because it's in quadrant 1, and we have numerator 17 root 13, denominator was 65. 17 and 65 cannot be simplified. If it can, then definitely simplify your fractions. Okay, moving on. Okay, this one's asking you to graph both sine. Now these are computer generated questions, so please make sure that you are able to graph sine, cosine, and tangent. Your part 1 and part 2 are not limited to just whatever is on like this practice. Please make sure that you look at the Are You Ready packets and your class notes for full things. So again, both of these are sine just because the computer generated it. Make sure you can graph sine, cosine, tangent. All right, I am going to do this on a separate sheet of paper just because I like to draw my graphs a little bit larger. And before I do that, I'm going to immediately notice that I have a -2 here in front of my +3 sign. This is your k value. This is your midline. So I'm going to place it in the back. So that's where that -2 is going to come from. Y is equal to 3 sine of 4 theta. You can change it to x. I probably will in a moment. 2 pi over 3, close it, and then let's put that -2 in the back. Step number 1, you want to factor out your b value. So what we have is 4, I'm going to change it to theta, or x, plus 2 pi thirds. So we need to pull out that 4. So the trick is you're going to pick up that b value, and you're going to flip it. So you're going to have 1/4. You're going to then pick up your given number, and you're going to multiply straight across. So 2 times 1 is 2. 4 times 3 is 12. Simplify that. So we get pi 6. That's going to go here. Some of you are skipping a step right now, like here, in that you are not rewriting your equation. So that's very important to rewrite. So I'm going to have y is equal to 3 sine of 4 of x plus pi 6, close it, minus 2. Which means that we have now a couple things to identify. This is going to be a positive function. It's going to be a positive sign. Again, open, close, and the middle is on the midline for the characteristics of sine. So it's going to look something like this. 3 is our amplitude, absolute value of A. Then we have our B value, which is used to finding period, 2 pi over B. Then 4 is not the period. Okay, B is not the period. It is used in our little mini equation here, which we need to simplify. We get pi halves as the period. Next, we have our start value. Again, opposite of what you see, always. And our midline. Okay, after you've identified these here, you're going to calculate 2 more values. You want the end value, which is taking your start and your period and adding them together. So start is negative pi 6 plus our period of pi halves. Common denominator, so I'm going to multiply top and bottom by 3. So it means negative pi 6 plus 3 pi 6. We have an ending of 2 pi 6. And simplifying that to pi thirds. And then the last one we need is your distance. For your distance, you're going to take your period. Your period is pi halves. And you're going to always multiply that. It's always going to be cut into 4 pieces for a total of 5 points. And we get pi eighths. Now, if you take a look at your distance, your end, and your start, all of them kind of have different denominators, which is not that great for us if we want to graph like on an easier section. So let's go ahead and do common denominators. And again, the common denominators that we want are from 3. We want the start, we want the end, and we want our distance. So I'm looking at 6, 3, and 8. So common denominator would be 24. The start right now is negative pi 6. The end right now is pi thirds. And the distance is pi eighths. So I'm going to be multiplying here by 4, here by 8, and here by 3. So we get negative 4 pi over 24. Here we get 8 pi over 24. And here we have 3 pi over 24. So these are the values that I'm going to be using and then re-simplifying later. Okay, let's go and, okay, before I start graphing, I'm going to take a look at my start. My start is negative on the x, my end is positive 4, sorry, positive 8. So when I'm graphing, it looks like I kind of need a little bit more of a balanced, but more on the positive x's. My midline is at negative 2 with an amplitude of 3. So I'm going to shift my x-axis a little up, giving myself a little bit more negatives on the y. Okay, something like that. I'm going to switch to pencil. Always graph with a pencil because you never know. You never know when you need to erase. So we have a start at negative 4. So let's pretend negative 4 is here. If negative 4 is here, pi over 24, negative 4, let's guesstimate. Negative 4 is another one here. So that means negative 8, positive 8. It would be around here. This is going to be your start. These are not asymptotes. These are just your indicators. And this is your end. Now you're going to use your distance of 3. So I'm just going to count by 3. 4, 5, 6. Just kidding. We're adding. We're going to the right. So 4 and 3 is negative 1. Negative 1 and 3. So that'd be around here-ish. 2. 2 and 3 is 5. 5, 6, 7, 8, and we have our total. You should only have 5 points. 1, 2, 3, 4, 5. Again, these are not asymptotes. These are just indicators. Now, things like this need to be simplified. So we're going to go back, and our start was negative pi 6. Our end was a pi third. This one, 5 and 24, cannot be simplified. This one can. Denominator of 12. And this one cannot be simplified. Okay, now let's go ahead and find our midline at negative 2. Negative 1, negative 2, midline. Next, we're going to find our maximum using the amplitude. So 1, 2, 3. Amplitude is the distance above and below your midline. So we got a max here. And we got 1, 2, 3 for our minimum value. Okay, so we have our little rectangle here to help us graph. What did we graph? We're graphing a positive sign. So a sine wave starts, stops on the midline, and find your middle point. That's going to be on the midline as well. Since it is a positive function, we're going to be increasing going up. So my first middle of the middle, so here's the middle, and then here's the middle of that, is going to go up. And then my second middle of the middle is going to go down to our minimum value. Now, when you're graphing, you must be careful not to go past your maximum and your minimum values. If you do, that means your max and min are not your max and min, and you've made a mistake. So carefully extend past, just slightly, but do not go past your maximum. Do not go past your minimum. So your graph should look something like this. Make sure these x values are simplified. If they are not, that would be marked as wrong. All right, let's go again. We have the next one as y is equal to 2 sine of, I'm going to change it to x, over 3 minus 5 pi thirds, close it, minus 2. All right. Step number 1, factor out b. What we have is x over 3 minus 5 pi thirds. And what we need is we need to pull out that number in front of x. So when you're looking at your b value, notice right now that we have a 3 in the denominator. So that means that 3 is going to stay in the denominator. We do need a number in the numerator, so we're looking at this number in front of x. Now, it doesn't look like there is anything, so you've got to ask yourself, how many x's do I have in the numerator? Well, it just looks like there's 1. So therefore, our b value is going to be a 1/3. We're going to open this up. X remains on the inside, and now we'll do our little mini equation. So we're going to take this b value, we're going to flip it. So now I have 3 over 1. I'm going to multiply that by the original value that they've given me, which is 5 pi thirds. When you're multiplying, you're going to multiply straight. We get 5 times 3 is 15. 3 times 1 is 3. Simplify. 15 divided by 3 is 5. So we get 5 pi. That goes here. Make sure at this point that you are rewriting your equation before you do any more identifying. We get y is equal to 2 times sine of 1/3 of x minus 5 pi, close it, minus 2. Let's identify. We do have a positive function again. It's not always positive. Make sure that you are aware of the differences between a positive and negative, and it's not always sine. Again, these are computer-generated questions. So let's go ahead and draw our little sine wave. Remember, sine function has a start and end and the middle on the midline. This is going to be positive, so we're going up and down. Next, we have our amplitude, absolute value of 2. Next, we have our b value, which is used to find our period. So I'm going to be dividing by 1/2, 1/3, that's a 3. Which means we need to do a keep, change, flip here. I'm going to do this in a thinking bubble here. 2 pi, keep, change, flip, times, let's flip it, 3 over 1, which means 3, 4, 5 pi is what we have. Okay, this is going to be your period. Oh, just kidding. I can absolutely do math. 3 times 2 is 6. We're not adding, we're multiplying. This should be 6. 6. Okay, next we have our start value at positive 5 pi and our midline, once again, at negative 2. Two more things that we need to solve. We need to solve for our end value. And our end value is going to be at our period and our start. So start is 5 pi plus our period is 6 pi. So 6 plus 5 is 11 pi. That's going to be our end. And then our distance is taking that pi sixth as our period, and you're always going to be multiplying by 1/4, always. So we get 6 pi over 4 divided by 2 divided by 2. 6 is 3, and this is 2. This is our distance. Now, again, if you take a look at our distance, our start, and our end, they're not common denominators. So once again, we need to do common denominators with those 3 values. And this just helps with the graphing. It's just a little bit easier this way. Now, what was our original start? 5 pi, I'm going to do over 1. End was 11 pi, I'm going to do over 1. And our distance is 3 pi halves. So I'm going to do a common denominator of 2. So we get 10 pi halves here. We get 22 pi halves, and our distance remains at 3 pi halves. So these are the values that I'm going to be using to graph. Right? Looking at these values, I'm noticing that my start is a positive 10 and my end is a positive 22. So I don't need negatives on my x-axis, but I'm looking at my midline, it's a negative 2 and an amplitude of 2. So I do need some negatives on my y's. So I'm going to do my graph kind of all the way to the left because I don't need any negatives on the y, sorry, on the x. And I do need some negatives here, so I'll do it. We can even extend this out a little bit further here. Okay, so we're kind of working in this section. Switching to pencil, I do recommend that. Let's pretend 10 is about here-ish, 10 pi halves, which makes 10, 20-ish. Let's just make that here at 22 pi halves. This is not an asymptote. This is your start. This is not an asymptote. This is your end. Now from here, you're going to use your distance. So 10, 11, 12, 13, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so we should, using our distance, end up at our ending number. 1, 2, 3, 4, 5. You should have 5 total. Then you're going to go back and simplify. So our original start was at 5 pi. Our original end, 22 divided by 2 is 11 pi. 19 and 2 do not get along. 13 and 2 do not get along. But 16 and 2 do. And that's going to be 8. Next, our midline is at negative 2. And we have an amplitude of 2. So 1, 2. Here's my max. And here's my 1, 2, my min. Okay, we have a positive sign. So positive sign means we're going to start. Where's my middle? Okay, here's my start, my end, and my middle on my midline. Then on my first middle, so here's my middle. My first middle of the middle is going to go up because I have a positive function. And my second middle of the middle is going to go down to my minimum. Again, when you're doing this, smooth curves, do not give me a sharp V. If it's a V, it's something completely different. Do not graph that. Smooth, 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 smooth. Use pencil. Now, once you're here, if you leave it like this is going to be wrong. You want to extend a little bit with arrows. This is continual wave. Think like the ocean. It's not going to stop. It's just going to keep going in and out. So like in and out like that. All right, beautiful people, that is it. Thank you for watching. Goodbye.